Okay, welcome guys. So today we will talk about properties of logarithms. This is section 6.5 from your textbook. Okay, so I'm going to list all the properties. I recommended to have them on the index card. First, I'm going to list 6 of them. I'm sorry, 7, 8 of them. It's 8 properties. I will list all of them so then we can just practice and start using them. So again, my recommendation is that you guys will have them together on index card, one index card. So when you're working on the assignment or when you will be taking a test, you have them in front of you. So properties of logarithms. Okay, so let's list all of them. First one, log of base A of 1, it's always equals 0. Okay, and I will be giving you example. Example, log of base 2 of 1, it's equals 0, because changing that to exponential will be base to the power of 0, it's equal to 1. Okay. The second property is log of base A of A, it's always equal 1. Okay, so when the base of logarithm is the same as the input, which is the number or expression next to log, it's always equal 1. You may even think a little bit that they are canceling each other. Okay, you may think that way. So this is equal 1. Let me give you example. Log of base 2 of 2. Since base and the input is the same, they will cancel each other, and that will be equal 1. And again, explanation, because, and I'm going to change that to exponential, base to the power, again, when you change to exponential, those two switching position. So base to the power of 1, it's definitely equal to. So this is correct. So on the right, I'm just showing you that it works by changing logarithmic expression to exponential. Number 3. So this one, you have an exponential expression, and the exponent is log of base A. So base of exponential is the same as base of log, and here you have m, that expression. So what's going to happen? The answer is equal m, and the best way to memorize that, the base of exponent is the same as base of log, so you may think like they cancel each other, like in example 2, and your answer will be m, the expression next to log. Let me give you an example of this property. Let's say you have 2 to the power of log of base 2 of 7. So how am I going to know the answer? Okay, I have exponents and logs, the inverses of each other. Since base of my exponential expression is 2, and base of my log is the same, so that means they will cancel each other, and your answer is going to be 7 in this case. Okay, so that's how it works. Okay. Next, property number 4. So I know it's new for you, that's why I really want you to have all of them on index card. So now we're going to do log of base A, and the input is A raised to the power of R. So it's going to be very similar. Base of log is the same as base of exponent, so you, again, think that way. maybe it's not really 100% correct way of thinking, but I'm trying to help you to memorize. So that means they will cancel each other and you will end up with r, the power. Okay, and let me give you an example. Logarithm of base 2, and the input will be, let's say, 2 to the power of x. Okay, so all the time when I see that the base of log is the same as base of exponential expression, they will cancel each other, and my solution is the remaining expression, which is the exponent of exponential expression, which is x. So that was number 4. Number 5, and this one we're going to use a lot. So this is product property, number 5. So product property, okay. So you're going to have a log of base A, and the input will be the product of m times n. This is equal to log of base A of m, and be careful here, not times but plus, multiplication become sum. So that's new, plus log base A of n. Okay, so when you have a product, that product becomes sum of logs. So let me just write this down. The log of product is equal to the sum of logs. Okay, so product becomes sum. Okay, we have to get used to of this one and memorize. Okay, number 6. Number 6 property. Okay, I'm sorry, let me just give you the example of this one first. So example of product property. So we have log of base 2, let's say 2 times 14. So what you can do with that, since you see the product, you can rewrite that as log base 2 of 2 plus log base 2 of 14. Okay, so I just show you. Of course, that can be simplified because the first one will give you 1. Okay, I'm just showing you how to use the sum, but if I would like to simplify that further, I have log base 2 in the same expression, so technically they cancel each other, and you will end up with 1 plus log base 2 of 14. Okay. Okay. Number 6. Number 6, it's quotient property. So this is how the quotient property looks like. You have logarithm of base A, and the input is the quotient. You have m over n. So you can rewrite that as log base A of m minus log base A of n. So the quotient become a difference. Okay, so we have to memorize that quotient right here become difference. Okay, so the quotient so let's put it better. The log of a quotient equal the difference of the logs. And let me show you example with the quotient property. Log base 2, let's say 2x over 5. So the major operation inside the log is quotient, so we're ready to use the quotient property, and we're going to rewrite that as log base 2 of 2x minus log base 2 of 5. Okay, and with logs you're always checking if you can simplify. So here actually we can do a little more work. Look, you have 2 times x, so it's a product. So here you can also apply the product property. So when you have log of the product, you can rewrite that as a sum of logs. So I'm going to rewrite log base 2 of 2x as log base 2 of 2 plus log base 2 of x. So again, I'm going back to the product property. And I'm going to copy minus log base 2 of 5. And now, since we're practicing, my base of log is the same as the input. So that means they will cancel each other. So this is the property right here, number 2. When the base is the same as the input, the answer is 1. So here I'm getting 1 plus log base 2 of x minus log base 2 of 5. So what I'm practicing right now with you guys, I'm actually practicing how to expand logarithmic expression using the properties. So that was the quotient property, number 6. Next one is the power property, number 7. The power property. I really like those properties, but again, I hope you guys will like them too. Log base a of m and you have power r. Okay, so what happened with the power? This is also new and it's only working with logs. The power, it's going right here in front of log. So this is the same as r times log base a of m. So you're moving power in front of entire expression. So let me just write the log of a power equals the product of the power and the log. And the log. Okay, so like you see, you have a power and we can move that power right here in front of log. So this is the power property. Okay, and there is one more, number 8. I'm not really using this one too much, but I want to put it that for you guys. A to the power of r, any expression to the power of r can be rewrite as e to the power of r times ln of a. Okay, I'm not really using this one a lot, but I want to just explain it why this one works. So because, and I'm going to start proving that actually from the right side, e to the power of r times ln a. So look what happened. Okay, I have an expression in front of log. I can move this back as a power. So I'm using the power property, but the one which you have on the right side, I'm moving r back to m right here. So I'm moving r back to a as a power. So this is the same as e ln a, and r was moved here. Okay. And now look what happened. We know that ln has a base of e, and your exponent, which is because we have exponential expression, also it's e. So what that means that they will cancel each other, and the remaining expression will be your answer, which is a to the power of r. So I'm just showing from where this rule comes from. Okay, I actually apply the previous properties which I gave you. Power property and the property when the exponential expression it's been bring to the power expression which has log of the same base. So they cancel each other. Okay, that's it. Next we're going to practice. I will just pause for a second. Okay, so we're going back. You guys have all the properties. Now let's start practicing. Okay, so we're going to do a lot of work. Again, let's start with number 15 from your textbook. This is page 459. In this problem, they want you to use properties of logs to find the exact value. And do not use calculator. So the idea is to get familiar with the properties which I just went over. So what you guys going to see? You're going to see ln e to the power of -4. Okay, so a couple things with ln. Okay, you guys know by now that ln is natural log, and each logarithm has a base. So base of ln is e. So always attach that e. Okay, so look what I'm going to do. Base of my log is the same as base of my exponential expression. So they will cancel each other. And the remaining power will be the answer, which is -4 is the answer. So which property I use? I'm going back to all those properties. I use this property. When the log has the same base as the input, which is exponential, that's fine, but it's the same base, so they cancel each other, and the power which stays, it's our answer. So that's the property which I use. Okay, so we will do couple. Number 19, the same instructions. You need to simplify using properties of logs. So in number 19 we have logarithm of base 8 of 2 plus logarithm of base 8 of 4. Okay, so what's going to happen here? I have two logs and a plus sign. So that's going to be the product property. So product property right here. So you guys have actually the right side of the product property. You have one log plus another log, and they have the same basis. You can rewrite it as a one log and multiply the inputs together. So this is what we're going to use. So that will become log of base 8, and we're going to multiply the inputs, which is 2 times 4. So we have log of base 8 of 8, and now look what happened. The base of log is the same as my input, so they will cancel each other. And when you cancel something completely, the answer is always equal 1. So the solution of this one is 1. And let's do number 23 from the same page. In number not 23. Actually, I will go back to 23 when I will teach you how to change the base of log. So we're not ready for 23 yet. We're going to do number 22. We have log of base 8 of 16 minus log of base 8 of 2. So I see difference. That means that difference will be converted to quotient. This is quotient property. So let's go back to quotient property. You have the right side of the quotient property. We have difference of two logs, and we can rewrite that as a log of a quotient. Okay? So quotient property. So we're going to rewrite that as a single log of base 8 and 16, the first expression. The first expression will be numerator, and 2, the second expression will be denominator. Okay, so you working from left to right. 16, it's on the top, 2, it's on the bottom. Okay, so what we're going to do next, simplify what you have inside of log. So you have log of base 8, 16 divided by 2, it's equal 8. And now we have the same case like before. The base of log is the same as your input. They cancel each other completely, so the solution will be equal 1. And we're going to do 26. So again, all those examples are from page 459. You can practice more of them, and of course you're going to see them on my MATLAB. So here they give you 5 raised to the power of log of base 5 of 6 plus log of base 5 of 7. So you guys really need to follow the rule of exponents, rule of logs, but order of operation. So you have 5, which is the base, and this is the power of 5. Okay, so what you want to do, you want to simplify first the exponents. So you have log base of 5 of 6 plus log base 5 of 7. So hopefully you guys recognize right now that when you have a sum of two logs of the same base, you can rewrite them as a product. So again, here, note, log base 5 of 6 plus log base 5 of 7. Okay, you allow to use here product property. Rewrite this as a single log of base 5, and you multiply the inputs. 6 times 7, so we have log base 5 of 42. So I will go back to our problem, and I will rewrite that as 5, bring to the power of log base 5 of 42. Okay, so I'm showing work. We simplify that exponent. Okay, so now what's going to happen, base of exponential expression is the same as base of log. What that means, that they will cancel each other, and the remaining expression is your answer, which is 42. So 42 is the final answer. I know that at the beginning it will take you time, which is normal. Have the rules in front of you and just keep pushing yourself, okay? Keep checking what rules you can apply. Okay, we continue practicing. Next, we're going to do a little different type of problems. I'm going to use still your textbook, and we're going to solve the problems from page 459, 29 through 36. And this is on page 459. So here, this is what they give you. Suppose ln of 2 is equal a, and ln of 3 equal b. Okay, so this is what is given. They're saying that ln of 2 is equal a, ln of 3 is equal b. Okay, use properties of logarithms to write each logarithm in terms of a and b. Okay, so they want you to rewrite each expression in terms of a and b. Okay, so what that means, a is ln of 2, b is ln of 3. So technically you need to use only ln of 2 and ln of 3. Use only ln of 2 and ln of 3 because ln of 2 is equal a and ln of 3 is equal b. Okay, so this is the note. And there's a couple problems. So we're going to start with 31. So again, all the problems from your textbook from 29 to 36, they want you to, they have one direction, okay? So in 31, you have ln of 1.5. So you need to rewrite that using only a and b. So before we convert to a and b, we need to convert that to use either ln of 2, ln of 3, or both of them. Okay, so let's think about 1.5. Okay, 1.5, it's definitely the same as 3 divided by 2. So I rewrite 1.5 as 3 over 2. Okay, so now look what happened. Here we have a fraction, which means quotient, so you can use the quotient property. You can rewrite this as the log of quotient, it's equal the difference of logs. So you can rewrite that as ln of 3 minus ln of 2. So the idea is to convert the given problem by using only ln of 2 and ln of 3. So now we're going back. We know that ln of 3 is equal b. So we're going to change ln of 3 to b minus, and we know that ln of 2 is equal a. So we have b minus a as the final answer. So this is our answer. Okay, so it's just playing with the properties. Okay, let's do 35. Let's think how we can work with 35. In 35, they give you ln root of index 5 of 6. So a couple things with those type of roots. So just remember that any root can be square root, cube root, can be rewrite as exponent. So if you have root of index n and you have x to the power of m, okay, you can always rewrite that as exponential expression, which means x to the power m over n, over whatever it's that index. Okay, so so this is the note. Okay, this is the hint for that problem. So let's talk about our problem. We have ln index 5 of 6. Let's rewrite that root of index 5 as 6 to the power, and again, you don't see any exponents next to 6. That means it's 1. So 6 to the power of 1 over 5. Okay, now we need to simplify that. Okay, so this is the power, okay? So you're going to use the power property. So when you have ln, an exponential expression, what you're doing with that power, you're moving that power in front of log. Okay, so I'm going back, I have those properties. We're using the power property, this one, number 7. You have a power, you can move it right here in front of entire logarithmic expression. Okay, so again, it makes sense. Before you guys continue with those lectures, rewrite them, rewrite all the properties on the index card so you can follow my explanation. So this is the same as 1 over 5 times ln of 6. Okay, so still not what they want, because they want you to technically use ln of 3 and ln of 2. So what we're going to do, we're going to break down 6 into 2 times 3. So let's just rewrite that. This is 1/5 times ln, and just rewrite 6 as a product of 2 times 3. Okay, so here, what you can do, you have log of product. That means you can use the product property. And you can rewrite that as 1/5 times. And the product will become the sum of two logs. So I have ln of 2 plus ln of 3. So the product, ln of product, it's equal sum of logs. Okay. And now, last thing what we can do, 1 over 5 times, and again, ln of 2, it's equal to a, that was given in a problem, and ln of 3, it's equal b. Okay, so don't forget that this is a, and ln of 3 is just b. So we have 1/5 times parenthesis a plus b, and that will be our final answer. Okay, 35. Let's do 36. So the same idea, rewrite given logarithmic expression using ln of 2, ln of 3, and later convert to a and b. So you have ln 4, root of index 4, and under root you have power, the fraction 2 over 3. So what we're going to do, we're going to rewrite that root as exponential expression. So this is the same as 2/3 to the power. And again, since you don't have a power here, so you're always going to attach 1 to the power of 1 over 4. Okay, so I use this property right here. Okay, so now have to keep simplifying. Okay, you see the exponent, you see the power. That means use power property. Power property means move that power in front of ln. So that will give you 1 over 4 times ln of 2 over 3. Okay, start looking better. And now, when you see a quotient, which is a fraction, that means quotient property. The log of quotient become the difference of logs, which means we copy 1 over 4 times. Since I'm going to have a difference, I'm going to put that in the parenthesis. log of quotient become difference of logs, so it's going to be ln of 2 minus ln of 3. Okay, and we have it, the same idea. Ln of 2, we know it's a, so this is just a, and ln of 3, we know it's b. So we're going to rewrite that as 1 over 4 times a minus b. Okay, so that's going to be the answer. Okay, so we did a couple problems like that. We're going to move to different examples now. So we're going to technically do the same thing. We're going to keep applying the properties of logs, which you guys have at the beginning of this lecture. And now what we're going to do, we're going to rewrite logarithmic expression using sum and difference. So technically we're going to expand. Expanding means you have something what looks nice and short, and we expanding to look longer, okay, using the properties of logs. So let me just write this down. So different, again, I'm not really introducing new properties at this moment. I'm just practicing with you. So different type of problems, writing a logarithmic expression as a sum or difference of logarithms. So what we're going to do, as a sum or difference, that means you're going to use the product property and a quotient property. So what you will need to do, you will need to expand, which means make it longer. You will need to expand the expression, okay, using the properties. And we're going to do a couple problems. So again, still page 459. And we're going to do a couple problems from this page. So let's do number 37. We're going to expand it. So that's the direction for all the problems which I will go over. So 37, you have logarithm of base 5 of 25x, and that's it. So it's a nice expression. We need to rewrite that as a sum or difference. So technically we need to expand it, make it longer. So first what I see, okay, I see 25 and x. So I know that there's a multiplication between them. What that means, you're ready to use the product property. The logarithm of product, it's equal sum of logarithms. So we're going to rewrite that as logarithm base 5 of 25 plus logarithm base 5 of x. Okay, so we're expanding. So logarithm base 5 of x, there's nothing what you can do here. However, 25, we're going to rewrite as 5 to a second power. So we're going to rewrite logarithm base 5 of 25 as logarithm base 5. 5 is the same, 25, I'm sorry, is the same as 5 to a second power. Okay, and I copy the rest, plus log base 5 of x. Now I'm using the property when the base of log is the same as base of exponential. What that means, they will cancel each other or they undo each other. So the remaining power, it's the answer. So we're getting 2 plus log base 5 of x. Okay, so which property I use here? Let's go back. I use property 4. Okay, so I use property 4 right here, the last one. So let me just write down. So I use here property 4. Okay, so that's our final answer. 2 plus log base 5 of x. So we expanded. Let's practice more. So again, when you guys see me watching the video, so I recommended that you copy the problem and you can pause, you can try to expand it by yourself and then continue watching lecture and just compare the results. Okay, so just the idea is to watching the video and study at the same time. You have log base 3 of x over 9 and we need to expand it. So what I see here, I see the quotient. I see quotient, so I already know I will need to apply quotient property. Logarithm of quotient, it's equal to a difference of logs. So I'm going to expand that as log base 3 of numerator minus log base 3 of denominator. So we need to expand it. So let's just talk about this. Log base 3 of x, there's nothing what we can do with this. So let's just copy log base 3 of x. Now here you have base 3 and you have 9. So 9 you're going to rewrite as 3 to a second power. So this is minus log base 3 and 9 we're going to rewrite as 3 to a second power. Okay, nice. Because now you can use the property 4 like before. Okay, so here you can use the property 4. Because the base of log is the same as base of exponential expression, so they will cancel each other and you will only end up here with 2. So our final answer will be log base 3 of x minus 2. That's it. That's the answer. So we're expanding. Right now we're expanding. Later we're going to actually work with what we have right now as the answer and we're going to condense, rewrite as a single log. So right now we're practicing expanding. I really have a lot of examples for you guys. Okay, let's continue. I'm going to do, this is number 38. Next one which I pick, it's number 40 from your textbook. So we're going to expand this expression, logarithm base 7 of x to the 5th power. Okay, so you see the power, that means power property. What that means, you're going to move that power in front of log. So we're going to rewrite that as 5 times log base 7 of x. And that's our final answer. So power property, going back to the properties. When you have a power, you can always move that power in front of log. Okay, so this one was short. 47. ln of x squared times square root of 1 minus x equal. So we have to expand it. So the major operation which you see inside of log, it's product. Okay, so what that means, we're going to use the product property. You really don't want to start multiplying them. No, just leave it as a product because we have nice product property for logs. Log of product is equal to the sum of logs. So we're going to rewrite that as ln of x squared because that's your first expression. And that product become sum plus ln of square root of 1 minus x. And you need to expand it, okay? So this is not complete yet. Okay, so we have to continue. Now, you have to have your properties in front of you because hopefully by now you see that we have a power property here. You see power, that means it's power property. We're going to move that 2 in front of log. So power can be moved in front of log. So this is the same as 2 times ln of x plus, and here when you have a radical with logs, you always convert that radical to exponential. So hopefully you guys see that square root of 1 minus x. Again, this is the expression. The power here, you don't see it, so it's 1. And the square root, the index of radical, it's 2. So you can rewrite that as 1 minus x to the power. So radicals become exponents, which are fractions, to the power 1. And the index of the radical is always your denominator, 1/2. Okay, so 1 minus x to the power of 1/2 is the same as the square root of 1 minus x. Okay, so they are equivalent. So let me rewrite that. Plus ln, instead of radical, I'm using the exponents of 1 minus x to the power of 1/2. Why we putting the radical as exponent? Because here we can use the power property, which means you can move that 1/2 in front of ln. So again, use power property. So that will be, let me copy that to ln of x plus 1/2 times ln of 1 minus x. And that's it. That's your final answer, okay? When you have expression next to log and it's a difference, there's nothing what you can do with that, okay? So this is our final answer. And I want to do 2 more examples. Again, keep practicing them by yourself with the quotient, okay? So something 51 and 55, I would say that they are advanced, okay? So if you can do 51, 55, you're good to go. You know what's going on with this class. So 51, okay? We have a log, and this log doesn't have an index. So what that means that this is the common log, okay? The base of that log, it's 10. Okay, so don't forget that if you don't see the base of log, so that's common log. I'll just review. Base, it's equal 10. So we have common log. The major operation in log, it's quotient. So we have x times x plus 2 over x plus 3 square. So a lot of things happening inside the log, but the major operation is quotient. So you want to start with quotient property. So you want to start this with quotient property. So log of quotient is equal to the difference of logs. So I'm going to rewrite that as log of numerator. And again, your numerator is entire expression right here. Okay, so log of x times x plus 2. Don't distribute that. keep it as a product because you can use the product property, minus log of denominator, which is right here, okay? So that's x plus 3 to a second power. Okay, and now we're slowly going to start expanding more. Okay, equal. So first of all, never FOIL here, okay? If you have logs, you always want to keep that expression inside of log as a product, okay? So what we're going to use here, we're going to use the product property. Okay, so after this example, I will stop and I will record one short video about how to condense. Okay, so product. So log of product is equal to the sum of logs. So you're going to rewrite this as log of x, and the product change to plus log of x plus 2. So we expand that. There's nothing else what we can do. Again, this one, log of x plus 2, it's not the same as log of x plus log of 2, okay? You will have a sum only if inside of log it's a product. So don't forget, product becomes sum. There is no property that sum becomes sum. Okay, so this is something that's it. We cannot simplify more. And I continue. Minus, and hopefully you guys see that we have an exponent, we have a power, so we can use the power property. We're going to move that power in front of log. So here we're going to apply power property. We're going to move that 2 in front of entire expression. So this is the same as 2 times log of x plus 3. And that's it. We expanded. Okay, this is our final solution. This is your answer. So expanding means you had something written under one log and you're expanding. And right now our final answer has 3 different logs. 55, it's the last one with expanding. Number 55. So we have ln 5x times square root of 1 plus 3x. So it's a multiplication here over x minus 4 to the third power. So I'm not going to write properties, but hopefully you guys see now that the major property is quotient. Of course I'll write. So you're going to start with quotient property. Maybe I over-explaining, but I really want to make sure that you guys know which property I'm applying. So log of quotient become the difference of logs. So that will become ln of numerator, which is 5x square root of 1 plus 3x minus ln of denominator, which is x minus 4 to the third power. Okay, so we expand it. We start with quotient, and now you have to expand it each ln, which you have. So a couple things here. Okay, don't forget that here between x and a square root, it's a multiplication, which is product. So you're going to apply here product property. Here you have a power 3, so you will apply power property. So let's continue working. So the ln of product, log of product will become the sum of logs. So this is the same as ln of 5 plus ln of x plus ln of square root 1 plus 3x. So product becomes sum. Minus, here what we're doing, we're moving that 3 right in front of ln. So we'll have minus 3 ln of x minus 4. And let's simplify better. So the only thing what we can simplify, we can rewrite square root of 1 plus 3x as the exponential expression, which is 1 plus 3x to the power of, okay, this entire expression, you don't see exponent, that means it's 1. Square root, we know the index of radical, it's 2. So this is the same as 1 plus 3x to the power 1/2. The index of radical is always your denominator. Okay, so let's just rewrite that as ln of 5 plus ln of x plus ln of 1 plus 3x to the power of 1/2 minus 3 ln of x minus 4. And the last thing, one more time, we're expanding. Here you go. We have a power, so you're going to use the power property. So again, this is, I will put a star. This one has a lot of work, okay? So this is finally the final answer. It's ln of 5 plus ln of x plus half of ln 1 plus 3x minus 3 ln of x minus 4. Again, I mentioned that this one cannot be break. Okay, it has to, this is the expression. There's no way that you can separate ln of 1 plus 3x or ln of x minus 4. So just keep it the way it is. Okay, this is final answer. So that was video 1. I'm going to record next video number 2. This is video 1. Okay, thank you for watching.